is Sevan Kumar or second CBZ, and today I am going to say about SN1 reaction, which is a unimolecular reaction, and the name itself says nucleophilic substitution unimolecular reaction. And let us know about SN1 reaction in brief. SN1 reaction means nucleophilic substitution unimolecular reaction. And that means only single molecule is present in that reaction, and we can also see the example given down there. And later, coming to the next point, in SN1 reaction, the rate of reaction depends upon the concentration of the substrate. Means the rate of reaction, either it be slow or fast, it depends totally on the concentration of whatever the substrate is present. And the equation is also given below. And the next step is, in rate determining step, the rate of reaction depends upon the concentration of alkyl halides. That means in rate determining step, whether it's a slow reaction or a fast reaction, the rate of reaction depends on concentration of alkyl halides. Means the rate of reaction, how fast it is, depends on alkyl halide concentration. You got the step right. It means the rate determining whether it is slow or fast, it completely depends on the concentration of alkyl halides, and the rate of reaction is first order. That means whatever the reaction takes place, it's always in the first order reaction, and it is simply called as unimolecular reaction. So as it is in the first order, so it is simply to be called as unimolecular reaction. SN1 can be explained by giving the following example. You can see that the tertiary butyl bromide with aqueous KOH gives rise to tertiary butanol. That is the example we can see below. Coming to mechanism, in alkyl halides, the C bond X involves ionization, which is a slow step. Ionization is a slow step to produce a carbocation. Means the carbocation is produced through ionization of C bond X, and the number of molecules involved in slowest step is rate determining step. Means what is a rate determining step? That means the slowest step in which the number of molecules involved is rate determining step, and it is also called as the order of the reaction. The formation of carbocation belongs to slow step. Means the carbocation which is formed, as we previously discussed, belongs to the slowest step, and it is rate determining step, so it is called as rate determining step. And the order of reaction is first order. In this also, likewise, the first one, this is also the first order reaction. And coming to step 2, in this step the formed carbocation is attacked by the nucleophile. In bracket we can see that OH minus to form corresponding alcohols. It is fast step. Coming to this is the fastest step, and in this step what happens is, the carbocation is attacked by the nucleophile to form corresponding alcohols. To form alcohols, the carbocation is attacked by nucleophile which belongs to OH minus, as written in the bracket, and we can also see the diagram below, and it is a fast step. And coming to the next one is the energy profile diagram, and we can see that one side is the potential energy and the other side is the reaction progress, and we can see that we have E1, E2 and E3, E4 in the graph, and the energy order is E2 is greater than E3 and the E1 is greater than E4. This is the energy order. Coming to the stereochemistry, when R2 means the R bond to bromobutane on reacting with aqueous KOH to produce an equal molar mixture of R2 butanol and is2 butanol forms a racemic mixture. We can clearly see that statement has been presented in the diagram form, and we can clearly know that. Another mechanism, we can see that step 1, in alkyl halides the C bond X involves ionization. Means the C bond X is gone through ionization and to produce a carbocation as an intermediate, and in the structure we can also see that it's a planar structure, and the formation of carbocation having planar structure, and the vacant p orbital, whatever the vacant p orbital is present, is perpendicular to the plane of the molecule. That means the vacant p orbital in the above diagram is perpendicular to the plane of the molecule. We can also see the below diagram. And in the step 2, the nucleophile attack on either front side or back side. We can see that whatever the nucleophile is present, it either attacks on the front side or the back side, because the carbocation having planar structure. Due to the planar structure of the carbocation, it attacks on the front side or back side. And it is also symmetrical. And if the nucleophile attacks at front, it is to produce retention of configuration. And if the nucleophile is attacking on the backside, then it is to produce inversion of configuration, and the final product involves racemization. In the given diagram at the top, we can see that what happens if the nucleophile attacks on front side, and also what is produced when the nucleophile attacks on back side. It is clearly present on the diagram, as you can see as follows. In practice, some of the reactions, one of the enantiomer is excess compared to others, which is depend on nature of substrate. As you know that whatever the nature of the substrate is present, due to that the enantiomer is excess compared to other, means in between them the enantiomer is excess or between them, and the excess of formation of the enantiomer is explained by formation of intimate ion pair. Whatever the excess formation of an enantiomer is there, it can be explained briefly by the formation of intimate ion pair. In intimate ion pair, both the carbocation, means both the carbocation and the leaving groups are present. Both are present in the intimate ion pair. And whatever the nucleophile can attack at backside of carbon until the solvent enters and leaving group is diffused. Finally, the nucleophile attacks on both sides of the carbon, which results are of the enantiomer forms excess. The given diagram also at the top states that the 3-chloro, 3,7 dimethyl octane, when retention that is 39%, and when inversion it is 60%. Coming to next, the reactivity order, 3 alkyl halide is greater than allyl halides, and benzyl halides is greater than 2 degrees, alkyl halides is greater than 1 degree, alkyl halides. This can be seen with example which is given below. And coming to the last part, the reactivity of alkyl halides, which means the whatever the reactivity can be explained by inductive effect. It can be thoroughly explained by inductive and hyperconjugation. And in alkyl halides, the formed intermediate, that means the whatever intermediate is formed is more stable, and such alkyl halide is more reactive, means the intermediate which is formed is more stable, and as it is stable, the alkyl halide whatever is there is more reactive compared to other. And the next one is the factors. What are the factors affecting SN1 reaction? And the first one is effect of solvent, which can be thoroughly seen by the diagram given below, which is that means it's not a diagram, it's obviously a reaction. And coming to the explanation, the SN1 reactions are favor in the presence of polar protic solvents. That means the SN1 reaction can be facilitated easily in the presence of polar protic solvents. And the protic solvent is also called as donor, but in some solvents the solvent can act as nucleophile, which involves nucleophilic substitution reaction with alkyl halide, and this process particularly is called solvolysis. And the next step is the carbocation interacts with lone pair electron of oxygen atom in water molecule, and the proton of water molecule interacts with Br minus, which is also called as the leaving group. And whatever the xn1 reaction is there, it favors a weak nucleophile which have lower concentration. And coming to the effects of leaving group, the best leaving group can facilitate the speed of the reaction, means the best leaving groups is useful for the reaction speed. we can see in the order of order of them, and that means the iodine is greater than bromine, and bromine is greater than chlorine, and chlorine is greater than fluorine. Let us discuss about the effect of nucleophile. That means how what the nucleophile really affects the reaction. In a sn1 reaction, the concentration of nucleophile is not influencing the rate of reaction. This state is that the concentration of nucleophile doesn't really affect the rate of reaction, because the rate of reaction is independent of the concentration of nucleophile. So the nucleophile doesn't really influence the rate of reaction. And generally, by taking a weak nucleophile, the reaction speeds up. Means if you want the reaction to be speeded up, you have to take a weak nucleophile. This is about the SN1 reaction in brief, with all the given steps and examples.